this is talking about angle of elevation and angle of depression, but I don't really like these pictures that are here, so I'm going to show you some that I've made in the past and just talk about this. So this I just want you to watch. Angle of elevation is whenever you're looking up at something. So like my little person here in this picture, he is looking up at the hot air balloon, and so the angle that you're looking up, that's angle of elevation. So if you're ever just looking straight ahead and then you look up, that angle that I look up is the angle of elevation. So angle of elevation is when you're looking up at something. Like you start looking straight ahead and then you look up. You tilt your head up. Angle of depression is if you look down at something. So if we actually had somebody in the hot air balloon person and they were looking straight ahead and then they look down at that person on the ground, that angle that they make is the angle of depression. And then one thing I wanted to talk about, do these two lines look parallel to you?
See.
If these two lines are parallel, what kind of angles are these?
Depression and elevation.
Alternate.
They're the same.
They're the same because they're what? They're alternate interior angles. So these two angles will always be the same. So the angle of depression will always be the same as the angle of elevation, which I'll show you as we do some more pictures. Okay, so looking at this picture here, I just want to practice vocab for a second. Angle 1. Do you think that would be an angle of depression or elevation?
Elevation.
Do you think that this is somebody up here on the mountain looking up or looking down?
They're looking down.
They're looking down. Here it's like they're looking straight ahead and they look down at the hiker. So if you look down at the hiker, that would be angle of depression. So angle 2, this is like my hiker. Here he's looking straight ahead and then he looks up at that mountain. So you would call this angle of elevation. Okay, angle 3. Here's my hiker looking straight ahead, and then he's looking down at this cabin. So this would be angle of depression, and this one? Elevation, because it's like maybe somebody was here out on the porch and they're looking straight ahead, and then they look up at the hiker. So when you look up, it's elevation. If you look down, it's depression. And these two angles will always be the same because they're alternate interior angles. Okay? All right, so I just didn't like these pictures here. The first one I want to do, we're going to flip the page, and we're going to do this one that says Example 5.
The one with the lighthouse?
The one with the lighthouse. So Example 5, the one with the lighthouse. And this is the same stuff that we were doing the other day. The problem is we have to draw a picture, and some of them are easier than others. Okay, so number 5. It says we have a lighthouse. It serves as a signal to ships as they come into harbor. It says if the angle of depression from the top of a 121-foot lighthouse to a ship coming into harbor is 16 degrees, how far out is the ship from the lighthouse? So I know it's a lot of information. When I read things like this, I tend to have to read them several times. So I've got a lighthouse. I'm just going to draw something. I don't care what it looks like. This is my lighthouse. Lighthouse. And it says, if the angle of depression from the top of a 121-foot lighthouse. Okay, so I know that this guy is 121 feet tall. And angle of depression, is that looking up or looking down? It's looking down. And he's looking down at a ship coming into harbor. So it's like here they're looking straight ahead, and then they look down at this ship. So here, like at the top of the lighthouse, you're looking straight ahead, and then they look down at the ship. And it says that angle of depression is 16 degrees. So my 16 goes right here. Sometimes students want to put the 6 doesn't go there, it goes here. Because here the person is looking straight ahead, and then they look down, so the 16 goes right there. Okay, and then they want to know how far out is the ship from the lighthouse. So if I want to know how far the ship is from the lighthouse, do you think I'm looking for this length, or do you think I'm looking for this bottom length?
The bottom line.
I'm looking for the bottom length. So go ahead and draw this piece down here and put an X there. Now, this is when I want you to know that since these lines here are parallel, these are alternate interior angles. So if this one's 16, this one's 16. So I'm just going to put the 16 right there. So this would be a little confusing at first, just trying to draw some pictures. So I just want you to know, depression is when first you're looking straight ahead and then you look down at something. So that's where the 16 goes. And then I can put it here because these are alternate interior angles. So now I'm not even going to pay attention to that. Okay, now this is what we were doing the other day. So my right angle's right here. Let me just scribble out this little 16 because I don't need it anymore. Do I have a hypotenuse in this picture? Nope. So then I go to the angle that's not the 90. What would you label the x?
Adjacent.
Adjacent. What would you label the 121?
Opposite.
Opposite. So what do we use if we have an O and an A? Tangent. TOA. T-O-A. TOA. So tangent. So tangent of what? 16 equals 121 over x. Am I finding an angle or a side? I'm finding a side, so no inverse stuff. The only time you do inverse is when you're finding an angle. Do you see how x is in the denominator?
Multiply.
Pop him up. So we're going to multiply both sides by x. When I do that, my x's are going to cross out. I'll have 121 left on the right, and I'll have x times tangent of 16 on the left. And then to get x by itself, what would you do? Divide by tangent of 16. And now I can just put that in my calculator. And so if I put 121 divided by tangent of 16, 421, it was exactly 421?
29.977147.
Okay, and then this one says let's round to the nearest foot. So if you round to the nearest foot,
422.
422. So x is approximately 422. And that would be feet if I were to label. Okay, so we're doing what we were doing before. It's just a matter of being able to draw the picture. Okay, do you guys have this next page that's attached?
Yes.
Because I know some of these were falling off when I passed them out that day. I want to go to number 12 on the very back. So if you don't happen to have it, maybe you can just watch and then I'll flip back. I just wanted to do this one because it was kind of like the last one. So number 12, it says an airplane pilot spots the control tower at an angle of depression of 47. So when it says angle of depression, looking up or looking down?
Down.
Looking down. Okay, so I've got an airplane pilot. Okay, so we've got this airplane high in the sky, and here he is looking straight out ahead, and then he looks down at this tower. And then I need to figure out where my 47 goes. Do you think my 47 would go here or my 47 goes here?
There.
Right here. So we've got our airplane pilot. Here he is looking straight ahead, and then he looks down, because that's what angle of depression is. Well, thank you. I thought it was quite nice myself. Okay, it says he knows that his altitude is 30,000 feet. What does that mean if that's his altitude? That's how high he is. So this side over here would be 30,000. That's how high up he is in the air. And then it says, what's the range? The distance directly from the plane to the tower. So if I want to know the distance directly from the plane to the tower, am I looking for this bottom piece or am I looking for this piece? This piece. Since it says the distance directly from the plane to the tower. So my x is going to go right there. And then if this is 47 degrees, I know this is 47 degrees because these are alternate interior angles. So I'm going to go ahead and I'm going to put my 47 right there in that triangle. And now I'm just going to scribble out that other 47. I don't need it anymore. And now I'm back to doing what I was doing before. I want to see if you can just set up the equation. So take a minute, figure out your labels, opposite, hypotenuse, adjacent, whatever, and see if you can just set the equation up. And then we can work it together. So I'm just looking for the equation, and my lucky person is Andrew. Do you have the equation? Just the equation.
So, sin 47 equals 30,000 divided by x.
Exactly. Did everybody know that we were using sine? The x is the hypotenuse. When you go to the 47-degree angle, the 30,000 is opposite. So sine of 47 is opposite over hypotenuse. So 30,000 over x. Very nice. And this problem is just like the last one. So how do I get that x up? I multiply both sides by x. And then after I multiply both sides by x, I have x times sine of 47 equaling 30,000. And your last move? Good. Divide by sine of 47. And after I divide by sine of 47, and this says once again to the nearest foot. Somebody have it? To the nearest foot?
I have it.
What do you got?
41,019.8. But I put 41,020.
Yep, 41,020. And this is all in feet. So rounded to the nearest foot, it would be 41,020. Okay, so the working them out is what we were doing. It's just a matter of figuring out how to draw it. Okay, I'm going to go back, this time to example 4. This one's a little trickier. Okay, so example 4, it says, Jackie is visiting the redwood forest. She is standing 55 feet from the base of a redwood tree and wants to determine the height of the tree. Okay, so I'm just going to start drawing some stuff. So I've got a tree. So here's my tree. And then I've got Jackie, little Jackie, and she's standing 55 feet from the base of a redwood tree. Okay, so here I'm going to put my 55. She's 55 feet from the base of the redwood tree. She wants to determine the height of the tree. So I'm going to want to know this whole height here. Thank you. And then it says, if Jackie's height to her line of sight is 5 feet, so that's what we need to understand. If Jackie's height to her line of sight is 5 feet, what do you think that means? Does anybody know?
Her height is 5 foot.
She's 5 foot tall, and that's like to where her eyeball is. So this would be 5 feet. So this is her line of sight to the tree. Here she's looking straight at the tree, and that's 5 feet. That's how tall she is to her, like her eyeball. And then it says the angle of elevation from her line of sight is 42. So if it's angle of elevation, is she looking up or looking down? Okay, so here she is looking straight at the tree, and then she looks up at the tree, and it says that that angle of elevation is 42 degrees. So my 42's going to go right there. And then it wants to know how tall the redwood tree is. So I'm actually going to have to do this in 2 parts. So do you know how I put that this was 55 down here? So do you agree this little triangle that I ended up making over here, that this would be a 55 right here also? Okay. And then if I want to know the height of the tree, I need to know this whole height here. Any game plans?
Isn't that bracket and then do a 5?
This guy right here is a 5?
Yeah.
So I know that this is 5 right here, so do I just need to know this piece? Okay, so I'm going to put my little X there. So I do need to find this piece right here. I need to know that this is X, but once I've got it, I'm going to have to add 5 to it to know the whole height of the tree. Does that make sense to everybody? Okay, so looking at this triangle right here, do I have a hypotenuse in the picture? No. And so then I'm going to go to the angle that's not 90. And what would you label the X? Opposite. And what would you label the 55? Adjacent. Okay, what am I using? Tangent. So it's going to go tangent of,
X over 55.
but before that, tangent of 42, and then x over 55 because it's opposite over adjacent. Okay, this one I like the most because x is up in the numerator. Am I doing inverse at all?
No.
No, because I'm not finding an angle. So how do I get rid of division of 55? So I'm going to multiply the right side by 55. I'm going to multiply the left side by 55. The 55s are going to cross out. Okay, calculator time. What do you get if you put in 55 times tangent of 42?
50.
Yeah, it should be around 50. 55 times tangent of 42. Yeah, I got a 49.5222.
Did you put the multiplication sign?
You have that in your calculator?
You're doing radians.
Yeah, and I will try to remind you on the day of the test to make sure your calculators are in degrees and not radians, because that will mess us up. I'm going to go ahead and put the 49.5. This one doesn't even tell me where to round. Okay, now that's just this piece. So what did you tell me I was going to have to do to find the whole height of the tree? Add 5 to it. So what do I get if I add 5 to that? 54.5. And that would be my final answer. And it doesn't, I don't see anywhere where it tells me to round. So I'm just going to leave it 54.5. Okay, let's go. There's a problem in your review. I just got to find it. There's a problem in your review that is like this one. So go to your review and let's look at, I'm pretty sure there's one like it. Number 26. So let's go to your review, and number 26 is like that one we just did. And see if we can figure out this problem. Okay, so it says on number 26, a person standing 30 feet from a flagpole can seek the top of a pole at a 35-degree angle of elevations. That just means they can see the top of a flagpole. And then it says the person's eye level is 5 feet from the ground. Find the height of the flagpole to the nearest tenth of a foot. I want to see if you can maybe try to draw it. So I'm going to give you a moment or two and see if you can draw it. And of course, you might draw it differently than I draw mine, but let's see if you can do it. So I'm just looking for a picture, that's all. Hello. Thank you. It looks exciting. Is it exciting? Do you know? If only teachers got Christmas bonuses, I would be excited.
You don't get anything for Christmas. They don't give you anything.
Well, we have our Christmas luncheon on Monday, where we have like 50 minutes for lunch. Yeah.
That means we get an extra long one.
Yeah, you have an extra long lunch. That's why I was saying if you want to bring a lunch or something, do that. Okay, do you think you have it? So I'm going to kind of draw it like I drew it last time. I've got a person standing 30 feet from a flagpole. And of course, you might have had your person to the right of your flagpole. I mean, I don't know. And then it says that the person can seek the top of the pole at a 35-degree angle of elevation. So they're looking up at the pole. And it says that the person's eye level is 5 feet from the ground. Okay, so this person's 5 feet tall, just like the last person. Here they're looking straight ahead. And then the angle of elevation, they look up at the flagpole. And that angle's 35 degrees. Okay, I know this bottom is 30. And I want to know the height of the flagpole. So I already know this piece is how much right here? 5. So I just need to find this piece right here, which I'm going to call X. And then I'll add 5 to it. And it's just going to be like that last problem. Okay, so now, do I have a hypotenuse in my picture? Nope, so I go to the angle that's not 90. And what would you label the X? Opposite. What would you label the 30? Okay, take a second and just write the equation. And it's stick time. Cooper. What do you got?
Tan 35
Equals?
x over 30.
Beautiful. I'm going to draw another stick, and this person can tell me how to solve this. Heather.
Multiply by 30.
That's exactly what we're going to do. We're going to multiply both sides by 30, and then those 30s are going to cross out. Can someone go ahead and tell me? This does say nearest tenth, so let's just round this to a nearest tenth in the calculator. 21. Okay, and then is that the final answer?
No.
What do I have to do again?
Plus 5.
Add 5 to it, and so the final answer would be
26.
26, and this is all in feet. You feel like your equations with the sine, cosine, and tangent are getting a little easier? Okay, sorry to keep going all over the place with you. All right, back to the packet. Let's look at example 3. Example 3 says we have a 25-foot ladder. It's leaning against the side of a barn, forming an angle of 50 degrees with the ground. How far up the side of the barn does the ladder reach? Okay, so typically when you have a ladder and you're trying to reach something, is the ladder completely vertical or is it slightly slanted? Okay, so slightly tilted, slightly slanted. So I'm going to draw my ladder like that. Of course, you could always draw it this way too. And then it says that it's a 25-foot ladder. It's leaning against the side of a barn. Okay, so here's my barn. Barn. And then it says it's forming an angle of 50 degrees with the ground. So here's my ladder, here's my ground. I need to figure out where to put that 50. Does my 50 go here?
No.
Here?
No.
Here?
Yes.
Right here. Because the ladder is making 50-degree angle with the ground. Here's your ground, here's your ladder. So if the ladder and the ground are making an angle together, it's that angle right there. So that guy's 50. And then it wants to know how far up the side of the barn does the ladder reach. So am I looking for this bottom length?
No.
Am I looking for this length right here? There we go. Okay, take a moment. Try to set up your equation. Start your labeling process. What's H, what's O, what's A, blah, blah, blah. And then see if you can set up your equation. And then I will call on someone. She feels sick, but she knows she won't throw up because she doesn't get sick.
I really don't.
We had a long conversation about it earlier. Okay, Zach, what do you have for your equation? Well, then I'm going to help you. Do you have a hypotenuse labeled in this picture? The 25 is the hypotenuse. Okay, then go to the angle that's not 90. What would you label the x? Opposite. So which one do you use? Sine, cosine, or tangent? Sine. After you write sine, it's always the angle. What's the angle in the triangle? 50. And then sine is what over what? So how would you write opposite over hypotenuse? Beautiful. See? You can totally do that. Okay. New stick. Colton, see? No, sorry. Looking at the wrong person. Colton, how do you solve that? Multiply both sides by 25. Beautiful. And then all you have to do is put that in your calculator and you'll get your answer. Can someone tell me what that is? 19.2. Well, oh, it doesn't say. Because it doesn't say, I don't know. As long as you're close, as long as you know what you're doing. Okay, I just want to show you one more. So I'm going to turn back and do example 1. So turning back, looking at example 1, it says a tree casts a shadow 21 meters long. And so they do actually have a picture here. So here's my tree. It's casting a shadow 21 meters long. And it says the angle of elevation of the sun is 51 degrees. What's the height of the tree? Okay, first of all, let's figure out where to put the X. What's the height of the tree? Would this be X? Would this be X? Would this be X? Okay. And then it says that the tree casts a shadow of 21 meters long. Do you know which one's the 21? The slanted or the bottom? It's the bottom. Your shadow, typically it juts out on the ground in front of you. So this is the shadow here. And then when it says the angle of elevation of the sun's 51, does that mean you're looking up at the sun or down? So if I'm looking up at the sun and that angle that I'm looking up is 51, do you think the 51 goes here or here? Camera 1, camera 2. 51 goes here or here? Right here. So angle of elevation here is straight ahead, looking up at the sun. The 51 would go right there. Sorry. I know, kind of old, sorry.
I love Wayne's World.
Okay, take a second and see if you can figure out your equation. Figure out what goes where. Opposite, hypotenuse, adjacent, and then I'm going to call on someone. Camera 1, camera 2, camera 1, camera 2. Have you guys seen Wayne's World?
Best movie
Wayne's
ever.
World, excellent. I was in high school. That's so sad when it came out. So funny.
We should watch the movie in class.
I would love to watch a movie in class. Unfortunately, math classes always get the shaft because we have to work. Adam, do you have it?
For this one, not yet. Let me finish it.
Finish or start?
Finish it.
Let me help you. Do you have a hypotenuse in this picture?
Yes. No, wait. No.
No.
There's nothing there.
So let's go to the angle that's not 90. What would you label the X?
The X. Opposite.
Opposite. And the 21?
Adjacent. Yeah.
Which one do you use, sine, cosine, or tangent?
Tangent.
Okay. After you write tangent, what's the next thing you write?
51.
And then tangent is what over what?
X over 21.
See? Easy peasy. How do you solve that?
Well, next you do 21 over 1, right?
Yeah.
Multiply by 21 over 1.
Yep.
You cross the 21 and 21 out.
And then I just put that in the calculator.
Yep.
Okay.
I'm a
So,
genius.
25 points. 26, right? That's 25 points.
okay. So somewhere close to that. All right, I will send you the link to the videos later today so you guys can watch them. The review is due on Monday. You should all be able to watch the video hopefully at some point. That should help you. Don't forget to make a note card. So, review due on Monday, test is on Monday, make a note card. Also, if any of you want to bring in supplies, if you haven't done that yet, you can still do it. You can't do it again if you've already brought in 2 until next semester. If you brought in 1, sure.
Yeah.
Wait, let me give you a donut and bring in supplies.